Hello there, I'm KSteve and this is KStevMath, and in this video I'm going to introduce to you the idea of using variables in math. So what is a variable? Usually it's a letter, and we use that letter to represent something that we don't know, or to represent something that we want to be able to change to other things. This allows us to write general rules that we can use over and over again. So maybe we have a situation where we know a lot of what's going on, but are missing one particular piece, then a variable would be helpful. Or maybe we have a formula that we want to use to be able to find the same information over and over again. We would represent the parts of that formula with letters or variables. So between those two kind of situations, you've probably actually seen variables before. So one of the ways that we use variables very commonly is with formulas. And so just to take a formula that I feel like you've probably seen before, the area of a rectangle is length times width. So I've got that on the screen here. A for area, the L, which is a lot of times kind of a cursive looking L so it doesn't look like a 1, L for length, and W for width. So see, they've named each of these with a letter that actually ties back into what it represents. As much as we can in math or science, we like to do that, but there's just sometimes not enough letters to be able to do that very easily. So occasionally you'll come across a formula that you're like, why is that the letter that's being used whenever that's not what that starts with, or things like that. It can be confusing, but for a lot of formulas we do have easy stuff like this where each letter is just the first letter of whatever it's representing. The other thing that you might have seen variables in are equations. Probably up to this point the equations you've seen have been relatively simple, like this one, x plus 5 equals 8. Maybe they didn't even use x though. Maybe they just had a blank or a question mark or a smiley face or something that just said, hey, find this thing that's missing. That's what we do in algebra, is we find what's missing. So in this case, you'd be like, what plus 5 equals 8? Well, that'd be 3, right? Because 3 plus 5 equals 8. So you've probably seen variables at this point, but if not, be sure to realize you're gonna be seeing them a lot. So I've got a couple skills we're gonna practice that have to do with variables. And the first one has to do with what's called an algebraic expression. So algebra, I don't guess we've talked about, algebra is a type of mathematics that tends to solve for unknowns, right? That a lot of people think of algebra as the place where letters all of a sudden are in math. So an algebraic expression is a set of numbers, operations, and letters that together can represent something. So it doesn't have an equal sign if it's an expression. That's an important distinction later on, at least, that if it just is something like this example, 2x plus 5, that's an expression. If I put 2x plus 5 equals and then a number or more letters, that's called an equation, because an equation sets two things equal to each other. So one of the things we can do with algebraic expressions with our current skill level that we've got is we can evaluate an expression. Evaluate's kind of a fancy word that we use, especially in math, that just means, hey, find what this is equal to. So this says, if x equals 5, what is 3x minus 4? Now a couple of things here. You may be new to the idea of these things next to each other that don't have an operation. What does that mean? So this 3x, I actually just realized that I might need to explain this. So 3x over here is saying 3 times x. Get it? And there again, once we get to pre-algebra or algebra, we stop using the times like an x, and we tend to use a dot instead. So another way we could have written this is 3 times x minus 4. It's always assumed that if they're right next to each other like that, that's multiplication. That's not the same as if we saw 3, 5. We wouldn't assume that means 3 times 5 because that's the number 35. So if you wanted to say 3 times 5, you would have to put a dot in between it, or we could put parentheses around each of them, something to show that we don't mean 35. Okay, that was a bit of a tangent. Now let's talk about x equals 5 in this expression. Well, if x equals 5 and x is right here, we should put the 5 where the x is. The equal sign in math means, hey, these are the same things. So where x is, we're going to rewrite and we're going to put 5. And now I do need a dot, like what I was talking about over here, so that we don't think of this as 35. Now there's some order of operations happening here. Hopefully you've seen some order of operations. You're definitely going to see some more during pre-algebra, but it's enough right now to just know that multiplication and division have to happen before addition and subtraction. And the way I kind of think of it is 3 and 5 are kind of almost glued together in a way. And then the -4 is kind of tacked on the end. So I always do the things that are like stuck together with multiplication or division first, and then I add or subtract whatever it might be to the side. It may be a little bit more complicated than that, but that's initially here something that we can use to help us. So 3 times 5 is 15. The other thing that we start seeing, especially once we get to pre-algebra and algebra, is the idea of showing your work. So if you were doing a worksheet for school and you were going through this, it could be that you just can look at this and say what the answer is, and that's awesome. If you're that type of person, though, let me warn you, you are going to be fighting a showing work battle for the rest of math unless you get used to the idea that just because I can do it in my head all at once does not mean that I should just write down the answer. There's a couple reasons for that. I don't know if this is really the place to go into it, but essentially your teacher needs to see what you're doing in case you're doing it wrong. So if you look at this and are like, oh, I know the answer, it's 12, and you write down 12, and that's it, your teacher has no idea if you just guessed or if you made a mistake somewhere. By the way, the answer is not 12. 3 times 5 is 15. 15 minus 4 gives us 11. So see, if I just wrote 12 and nothing else, the teacher would say, well, you might have done it right and just made a little mistake when you did 15 minus 4, but I have no way of knowing that as a teacher because I can't read your mind. The other thing about showing work is in pre-algebra, typically your teacher doesn't want you to rely on a calculator, and that's because it's so important to have the math foundational skills to back up what you're trying to do. So if you just write 11 as your answer here, your teacher doesn't know if you got that on your own in your head or did you put it in a calculator, and they probably don't want you to put it in a calculator. Checking your answers in a calculator is different than just doing it in the calculator. So anytime you have a worksheet and you've finished it and you're like, oh, I want to check my answers, using a calculator at that point, yeah, that can be okay. But the first time through, you don't want to use a calculator, you want to practice your math skills. Well, maybe you don't want to, but your teacher does. All right, let's do another one of these, see if we can make sure we understand what's going on. Now at this point, hopefully you've got pencil and paper, you're following along, you're in a quiet place, and you're writing things down. If you haven't been, this is a good place to start. So if you were taking notes in a math class as opposed to watching this video, your teacher would hope that you'd write down this example. And you'd write it down the way it is right now. So you may need to pause the video so you can write it down. And then you'd also write down whatever the teacher writes down to show how it's done. And the idea there is that when you're looking back and studying for a test or something like that, that you have information that makes sense to you. So if you haven't been doing that, this is a great time to start. The other cool thing that especially you can do with videos, but you can also do in person, is you might be saying, well, I get what you just did, so I'm good. I don't really need to watch the rest of this. Well, there's another type of problem, so don't you dare turn the video off. But also, this is a good time to check and see if you really understand it. You can pause the video, or if you've just been doing it while I've been talking, that's good too. You can pause the video and figure it out yourself, then play the video and see if you got the right answer. And if you didn't, hopefully I'll help you figure out why. So that's a really cool skill that you can develop as a math student. That it can be frustrating for teachers if you're working too far ahead, but if you're working ahead to see if you've got it, that can be helpful. Now, if you work all the way through the examples on some paper and the teacher's on example 1, don't ask about example 8 or whatever it may be, because they don't want to. That's not how that's supposed to work. Oh wait, anyway, evaluate an expression. If x equals 3, what is 10 minus 2x? So notice our x is in like a kind of a different place here now, right? 10 minus 2x, but this 2x still means 2 times x. We're going to put the 3 where the x is, so that I'm going to do 10 minus 2 times 3. Now, we said multiplication comes before addition or subtraction. So I'm not going to do the 10 minus 2 first. The only time I would do that first is if there were actually parentheses around it. We could have a different problem that might make us want to do this, okay? But they have to specify, hey, do this part first, or we're going to default to doing multiplication and division first. So I'm going to do 2 times 3, which is 6, so that I get 10 minus 6, and then 10 minus 6 equals 4, and that's my answer. And notice I think I did this on the last one. I like to box my answers, or maybe you like to circle your answers. That's just a way of showing your teacher where the answer is so that it's easier, especially if you write messy. It can be nice to be like, oh, there's the answer, right there. Alright, we're going to do a new type of problem now. And this type of problem is called adding like terms. So, in this case, my instructions say simplify the following expression. Simplify is just a word that means, that basically means make this smaller than it is right now. So for instance, we have 4 things here. And let me help you see that there are 4 things. So we have 4 things here. Let me make sure that we see the same 4 things. 4x together is a thing. It's called a term. 5 is a term. 10x is a term. And 1 is a term. This is how we break up things in algebra. So that idea of multiplication making things stick together is kind of reinforced here because 4x, we say it like it's together, right? It is a thing. There are 4, we're kind of saying there's 4 x's. So if we're looking at this problem, it says simplify. So we want to be able to combine some things based on things that are the same. So we want to look at these things and see what is alike that I can add together and what should I not add together. And if this is your first time seeing a problem like this, it may not be obvious to you. We call this adding like terms because we look for the terms that have something in common. And the thing that's going to be in common is whether or not they have an x or not. So you'd kind of think about it like the x is representing something. So if I have 4 of these x's, whatever they may be, I can't add to that 5 of something that doesn't have an x with it. That's not going to make sense. But I can take 4 x's and I can add them with 10 x's, and then how many x's would I have? If that still doesn't make sense, replace it with apples. If we have 4 apples and we add 10 apples, how many apples do we have? We have 14. So together, 4x and 10x make 14x. And then the 5 and the 1, which are just normal numbers, they can be added together as well, which gives us 6. So this is what we were going for. We've simplified. I can't add 14x and 6 together because they don't both have x's or both not have x's. So this is actually maybe going to be unsatisfying at first because you may not be used to ending up with answers that aren't just numbers. And that's fine. You'll get used to it. But the key thing, this is going to matter a whole lot all through pre-algebra and algebra and beyond. The key thing is that we need our variable to look the same in order for us to add things together. So let's look at another example that looks a little different. Okay, whoa, this is longer. So it says simplify, so we're trying to make it look smaller, which we should be able to do. But not only that, we've got 2 letters now, not just one. We have x's and we have y's. So, just like in the last problem, we're going to add the x's together. So 7x and 2x together gives us 9x. Sometimes on problems like this, I actually will underline and say, okay, 7x and 2x, those are like terms, so that it sticks out to me. Together that gives us 9x. Another thing you could do is after you've added those together, you could mark through them. Although if you're taking notes, you want to be careful so that you can see the original problem. Marking out those x's helps us see that we've already got them taken care of, and hopefully we won't accidentally add them in with something else. Now, we've got y's this time, which we didn't before, so hopefully it makes sense to you that we would add the y's together because they have the same kind of variable. So 9y and y are going to add together, but what does that mean if it just has y? What number would go with that? So let's think about it. We have 9y, and we're adding another y, so we should add 1y. You may have thought that it would be 0y, and if you did, that's a really good guess. But the reason it's not 0y is because if it was a 0 in front, 0 times anything equals 0. So if they meant 0y, they actually wouldn't have written anything there. So 1y we just write as y, or 1x we just write as x. The biggest reason for that is that mathematicians are lazy, and they're going to try to write as little as possible. So 9y plus 1y is 10y, or if another way of thinking of it, you've got 9y and you're adding another y, so that's 10y. So I've got my y's. Now I'm going to do 8 plus 3, which is going to give me 11. Now look at these 3 terms I have left, 9x, 10y, and 11. Can I combine any of those? Well, the answer is no. I can't combine an x with a y just like I can't combine apples with oranges. If this was saying we had 9 apples and then we had 10 oranges, we can't say we have 19 apples or 19 oranges. We have to keep them separate. Of course, in real life we could just say we have 19 fruit, but then what variable would we use for that? We'd have to make up a different one, right? Couldn't be x or y. So we just don't do that. We leave them separate. And then the 11, which doesn't have an x or a y, is also separate because you can't add something without an x and a y to something with an x or a y. I'm also going to throw this out there, although I'm not sure how much it happens in pre-algebra because it's a little more tricky. If you were to see 2x plus 3x squared, right? This 2 right here means squared. Those actually are different as well, because if we knew what x was, let's say we knew that x was 5, then what's happening here is that this has 2 5s, is what it's saying, but here we have 3 of whatever 5 squared is. Here we really have 3 25s, not 3 5s. So we can't just add them together if they don't have the same exponent. That may be a little bit more than you needed to know right now. You may be able to ignore that for a little while, and that's fine. Let's look at another one and change it up. Now, do you feel like you've got the hang of it? I really encourage you to try this one on your own. So pause the video and then start it back up once you're done. If you get stuck, that's fine, but at least try it and see if you understand some of what's been going on here. You're back. Okay, so we have different letters here than we've used before, N and M, but otherwise it's going to work the same way as what we did in the last problem. So they're also not in the exact same order, so we have to pay more attention. We've got 8n and n that we're going to add together. So 8n plus 1n is 9n. So maybe this is nachos. 8 nachos plus 1 nacho is 9 nachos. And now you're hungry for nachos. Hopefully not. Then we could say, all right, I've got those taken care of. What about this 3? Is there another number somewhere that I can add to that 3? Yes, there is. I can add this 2. 3 plus 2 is 5. And then finally, 7m and 6m add together because they both have m's, so that adds together to get 13m. So, did you get it right? Or did you get stuck somewhere? Most importantly, if you got it wrong, did you figure out where you went wrong? Because that's really where the learning with math happens, is that yes, it's helpful to see somebody do it, but then you've got to try it on your own, but hopefully in such a way that if you're doing it wrong, you can see right away and correct whatever it was that led you to get it wrong. So hopefully I've explained how to get it well enough that you know where you went wrong. Hopefully that's the idea. I guess we'll see. Feel free to leave me a comment if there was something that needed more explanation. And that's all for this video. So we've got a better understanding of how variables work in math, and we will build on that for the rest of pre-algebra, then algebra, and then just keep going on from there. Letters like never leave after this point. Thanks so much for watching. I have a cool website that you can check out that actually has some practice problems that you can do like this. And basically the idea is that it gives you a problem, you try to figure out what the answer is, and it shows you the answer so you can see if you did it right. It's so important in math to practice with the idea that you know right away whether you're right or wrong. Anytime we can do that, we will be better at math than if we are doing it and then having to wait a while to see if we got it right or wrong. So head over there and check out Pre-Algebra on that website, and then go to Understanding Variables, and you'll find those little applets that let you generate over and over new questions. Thanks so much for watching. Don't forget to like, comment, subscribe. Bye.